Okay, guys, stop talking.
Put a voice muffler so she doesn't answer.
Stop talking. I'm ready to start.
Is it recording?
Yes. Okay, so section 7 is all about simulation. Simulation goes hand in hand with the relative frequency approach to probability. So what we did this chapter was we did the classical approach to probability. So we used formulas, we thought about the theoretical world. Relative frequency approach is generally used when you can't calculate the probability of an event, so you carry out a simulation instead. Simulation is meant to model real life, but it's generally done by a computer. So for example, if I wanted to take a fair coin and flip it 100 times and see how many times I got heads, rather than flipping it 100 times, I could carry out a simulation. So let's say heads would represent, or 1, the number 1 would represent heads, the number 2 would represent tails. I would just randomly generate 1s and 2s, and that would give me my heads and tails. That's the idea of a simulation. Does that sound familiar? Something you guys have talked about? Okay, we're not going to do any of the actual computer stuff. We're just going to design a simulation and do it by hand. This relates very much to choosing a simple random sample using a table. Do you guys remember that? When I said you have a group of 100 people, you want to choose a sample of 3, you would give each person 2 or 3 digits and go along your table. That's pretty much what we're doing today. So, at the top of page 23, it says notes. All I want you to do is write down the process for a simulation. So for each simulation, you're going to use this table right here, so a random integer table, or the one that I give you. There are 4 steps. First step, you have to define your digits. So tell me what digits 1, 2, 3, etc. represent. And then you also have to define your process. So where am I starting? Am I looking at 1 digit at a time, 2 digits at a time, etc. Next thing that you have to tell me, are you using replacement? So once I get the number 2, can I get the number 2 again? Third thing that you have to tell me is your stopping criteria. How do I know when I'm done with one trial? Last step, you have to tell me what are you going to record. So once you've done your one trial, what are you looking at in that one trial? And after recording, you actually have to answer the question that's posed. When you define your digits, every object has to have the same number of digits. So if I have 15 objects, the first one would be 0, 1, 0, 2, 0, 3, all the way up to 15. And then also you don't have to use all of them. So if I only have 4 objects, I might use the numbers 1 through 4 and then not use 5 through 9 and not use number 0. So I think it's best if we just do an example. Sound good?
Yeah.
Okay, great. Here's the example that we're doing. A basketball player makes 70% of her free throws in a long season. In a tournament game, she shoots 5 free throws late in the game and she misses 3 of them. The fans think she was nervous, but the misses may simply be chance. You would like to address the nervousness issue by estimating the probability that she misses 3 or more. Okay, so we are going to describe our simulation and then we're actually going to do it. So first thing, define your digits. So it's saying she's shooting free throws. All we care about is if she makes the free throw or if she doesn't. So that's what our digits need to represent. So the digits, I'm going to use 0 through 6. So those 7 digits represent making the free throw. And then therefore 7 through 9 represent missing. Okay. Then the process, I'm going to start at line 101. And I'm going to look at 1 digit at a time. Am I going to use replacement? All you have to do is look at the digits and say, do they represent like a specific instance or a specific person or something like that? No. So in this case, you're going to use replacement. If we didn't use replacement, and let's say we got the number 6, we would then only have digits 0 through 5. That's no longer 70%. See what I'm saying? Okay. So that's step 2. Use replacement. When am I going to stop? She makes 5 free throws. So you stop after 5. I think that was the 3rd step. Okay, 4th step, what are we recording? Out of those 5, what do I care about? The number of misses. Right, because we're estimating the probability that she misses 3 or more. So I want to know, did she miss 3 or more? Okay, this is one trial. Now, with a simulation, you want to take a whole bunch of trials. That's what the law of large numbers says. The more trials you take, the closer you're going to get to the true probability in general. So this is one trial. So we're going to repeat. And then we are going to count the number of times that she missed 3 or more. Bobby?
Would you have to say repeat starting on like a different line or something?
No. So, starting at line 101, we're going to look at these 5 digits. She made 1, she missed 1, she made. So we're going to record the number of misses. So in our first trial, she missed once. This is our second trial. She misses once, and then she makes it 4 times. This trial, she misses once. This trial, she misses twice with the 8 and the 7. This trial, she misses twice. And then one more just for fun. This one, she makes all 5. She doesn't miss at all. Okay, so now we need to answer the question. The question says, estimate the probability that she misses 3 or more. Based on our simulation, what is our probability that she will miss 3 or more? 0. So we're going to say, based on our simulation, we estimate the probability that she misses 3 or more free throws to be 0. What does the probability of 0 mean?
It never will happen.
It's never going to happen. So I am very hesitant to say that a probability is 0. So I always say we estimate it to be 0 or very small. Or very close to 0. Because it is possible. It's not an impossible event. It's just very, very unlikely. Okay, what do we think?
Cool.
Not bad? Can I just throw you into trying one on your own? Great, you're trying the one on the next page. With your partner. Good luck.
How are we doing? How are we dealing with this? Yeah, we'll go this way.
So 0 through 5 for the 6 rows,
0, 1, 2, 3.
What?
Is it 35?
So like every box of cereal has
Yep.
everyone has one.
You could, yeah. You can start with whatever you want. What do your digits represent?
So is there like a definite answer for every question, or is it just how we?
It's how you define it.
Just get anything above
So if we were to find our digits from like 1 to 6, can we just say skip digits 8, 9,
6, 3, 9.
Just say ignore digits.
Oh, okay.
Yeah, I'm gonna say user first. Stop.
Here's the thing, the homework is automatically.
Without replacement.
Represent a 12.
Oh no, I have an idea. I'll get a copy here. I'll have something faxed.
But you can't do read.
That means you can't pick another number.
So the way it works is you go to the grocery store,
Yeah.
you buy the box, you go home, you see your choice. So if you use replacement, that means you could get one and then one again.
Yeah.
Which means you get the same toy twice. Is that
So
possible?
with-
Yes. Yeah. Because it's not like you're gonna get home and say, oh, it's the same toy and then you can fast them.
Yeah.
I mean, you get the same toy. People probably do that. Okay. Unrelated to
But like, okay.
Stop
Right?
Stop after you.
Start at 5,
Okay, yeah.
7. We got one digit.
in all reality, it's in this scenario.
Oh, we have
You have all the toys.
I just
You
said
can't stop if you get all 6 extra.
Because all of the boxes have those. You can say like 7 if you don't get it.
How many numbers? How many viable numbers you have?
Yeah. Oh shoot, would that be this first step?
Oh. Or in order to see like how many digits
We see this is one child. Count numbers.
Because think about numbers. Oh, that's pretty much a battery box.
Do me a favor, Alex. You lost your packets, you're not actually showing them.
1.
Just say stop after 5 minutes.
Maybe.
So stop it for you get at least one of each of them.
Now approach it and actually.
Oh, wait, we're not supposed to count the
Like, so you get all
boxes.
6 toys.
Well, tell them it was left in.
And then
1, 2, 3, 4, 5, 6,
Nice
7,
charger.
8, 9.
Okay, do we need like 2 or 3 more minutes?
Yeah.
Go ahead, hold on.
It fell off. It's a sticker was not sticking very well. So I decided to keep buying
The number of repeats.
next dinosaur sticker I can place it
How many boxes are one?
I just mean, like, maybe consider one digit. So what I meant was look at one, not 19. So like one represents something, not two represents
But then would you?
Did you actually carry out the simulation?
So we get 2, 3, 5.
What's your answer? Oh.
Says after carrying out the first trial is projected to take 35 boxes 0 to receive all 6 toys.
Okay, more than one trial.
So how many trials are talking?
You need two?
I said do 6.
Okay.
6 trials.
Go for it.
Do we have to record each trial or?
Yeah.
Should we go to
We estimated.
4, 2.
Okay, we are going to start going over this. The biggest deal to me is that you designed the simulation well. I don't think we need to spend 5 minutes actually carrying it out. Are we done designing? Yes. Okay. Okay, well, this is what I did for the last class, so it's already here. I used the digits 1 through 6. So a lot of you, I think, did 0 through 5, which also works. Digits 1 to 6 represent the 6 different toys. I started at line 107, and I looked at one digit at a time. You want to use replacement, because you can get the same toy twice, or 3 times, etc. Did you tell me to ignore the other digits?
Of course.
So I ignored 0 and 7 through 9. Stop after obtaining all of the digits 1 through 6. Record the number of digits. This is one trial, and then repeat. How'd that go? Okay. And then did we actually mark it on the table? Okay. Show of hands. How many do you use 0 through 5? 1 through 6? Okay, I'm going to go 0 through 5 then. This is what I would have done. Cross out the ones that you're ignoring. I would have circled the new ones. And then that is just a repeat. So repeat, repeat, don't use, repeat, repeat.
7.
So, so what am I looking for? A 1, 4, and a 1. Okay, so 4, 1, don't use, repeat. And then put a line for one trial. So then you want to look at the number of boxes. So in this first trial we had to open 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. Did anybody do one past that? We only did one trial? Oh, okay. What did we get for the second trial? 17? Okay, so I'm going to go based off of those. And then we have to answer the question. So the first question we did about the free throws, your answer was a probability. This time it's the number of boxes. So you would say, based on my simulation, I estimate that a customer will have to buy 13.5 boxes on average to receive all 6 toys. How do we feel about this?
So on quiz, do we have to do 2 trials or?
I'll tell you. It's going to be a small number, like 2, 3, maybe 5, nothing more than that. Do you guys recognize that our answers are going to be different based on how we define the digits?
Yes.
Okay. What are we assuming for this example?
There's an equal chance to.
Yeah, we're assuming that there's an equal probability for each toy. Okay, one more example. Woo! Okay, this is the one that you are doing. That's a family band. I don't know what their name is. They're a traveling family band from before all of our time.
That's what I had when I was on the trials.
Couple wishes to have at least one child. But if you're to have a maximum of 4 children, what is the probability of
You'll know when
one child's gender? Is it just one digit or will it be like a range of different digits?
You can do either one.
Do like 0 to 4 represent a boy, something like that? Or no?
That's exactly what I did.
Okay.
Good quiz. Good job, Lindsay.
It was probably how you play
Oh, you need like 3 digits.
Oh, Natalia.
And you were 5 minutes too late.
Yeah, I just brought it down to the help desk, and now they're
Okay.
just go down to the help desk, and then the lady's gonna say, "Oh, you're double bad because you didn't have a case on it," and then yeah, and no, I was just like,
You're gonna get yelled at now.
no, I pressed the home button and saw one of the emails said like, "Hey Natalia" or something
Wow,
from
so
a
you read
college.
her email?
I did not open it,
So you
but then
read
and I was like,
her
"Oh, I should just
email.
bring this to Natalia's class," but then that would not be following.
I
the
looked it up and
instructions.
she's very far, so.
Why? Where? How far? Like.
It doesn't matter at this
by
point.
the gems.
Go to the help desk.
Bye, Natalia.
Should have used the case.
Double bad.
Yeah, that's what the lady said, and I just was like, lady, like, lady.
Wait, what happened?
Natalia left her iPad in here and Alex took it to the help desk. But it doesn't have a case on it, so she's gonna have to explain herself.
Cases are for you.
Yes.
Come on, you guys have got 2 more minutes, let's go.
Oh, hold on.
Can we say stop after 3 digits or when one of each gender?
Stop it.
Because isn't like double maximum? So should I, we say stop after 3 digits or when? It says if we want to have a maximum of 3 children, will we say stop after 3 digits or when one of each gender is? Or should we just say stop after
Successful if there's one of each gender, so there's one. Yeah, if it's not successful.
Stop after 3 or whenever one of each. I would say whichever one is so that it doesn't leave you. Because if you just say either or, then I can pick one.
I'll read you what it is. I have 4 boy, 5 girl, stop replacement. Stop number 3 members are selected to represent the maximum of 3 kids or when each gender is selected. So the first one, and then you say trial to substantial.
That'd be like 183. Just say 4 or 5.
Wait, why can't you do that?
Because that means they're having 3 children every time. Which they're not.
You know,
Based on my simulation.
Boo, yeah, I agree. Boo.
Alex, you can't disagree every time that you're wrong.
Yeah, so it's
So, I mean,
they
they might have 3 children
after already having 2 genders.
No. It says they want to have at least one of each with a maximum of 3. So that implies if they have girl, boy, they're done.
And if they have boy, they're gonna have
A
another
third child.
They can have one girl to go, I want another kid.
It's the
All they
American
care about is
dream.
one of each.
They said at least
Gender.
one of each, they didn't say one.
Yeah.
Well, you have to say the at least part because if they have boy, boy, girl, then they have at least one of each.
The probability that
Yeah, they're not having 3 kids. They're having 2 if they have both genders and they're done.
Where's her?
No, they can have 3 kids, they can have 2 kids, you know? They can have 1 kid if they become infertile.
They want each gender, and then if
They
they
want
have,
each
if
gender.
they get 3 girls and 3 boys, they're not gonna have any kids.
Right.
But if they have a girl and a boy, they're just
Right. Yes.
They want at least one
Alex,
of
it's
each.
not that big of a deal. Okay.
Alright, well, I've already written most of this, I don't wanna.
Okay. Let's just talk about what you should have done. I'm not gonna write it down, I'm just gonna talk. So for my simulation, I said 0 to 4 represent a girl, 5 to 9 represent a boy. Start at line 117, look at the first 2 digits. If one of each gender is had, you are done. If both children are the same gender, go to the 3rd digit. That is 1 trial. Record whether or not there is at least 1 child of each gender. Is that clear? Without me actually writing it down? Okay. Questions on this one?
No.
Questions on anything related to simulation? No.
Is this all we're gonna do on the quiz, like the type of problems?
The quiz is going to be similar to